My name is Anthony Nathaniel, and today I'll be continuing our series on chemistry. And today our topic is acids and bases. Now, acids and bases in chemistry, they are very important parts of every chemical reactions, because acids, they are the catalyst of neutralization, and neutralization is kind of a reaction that takes place in every reaction. Most reactions, not every reaction actually. So most reactions, most important reactions involve neutralizations, and neutralization produces water. So today we are going to be talking about acids, bases, and salts, and we'll talk about the properties and preparations of acids, bases, and salts. Then we'll talk about neutralization. So first of all, what's an acid? An acid is basically any substance that produces hydrogen ion or hydrozonium ion as the only positive ions in a solution when it is ionized in a solution. Now, what that means is that whenever you dissolve an acid, so for example, whenever you dissolve hydrogen chloride gas in water, that hydrogen chloride gas will dissolve to produce hydrozonium ion as the only positive ion in that solution. So that solution of hydrochloric acid, HCl, will have the hydrogen ions from that acid. They will become the positive ions, or the hydrozonium ions. And the hydrogen ions, they are known as H positive, a H with a positive at the top, and then the hydrozonium ions, they are H3O positive. So either it produces hydrogen ion or hydrozonium ion, is still an acid. Now an hydrozonium ion is formed whenever you have the hydrogen ion from the acid reacting with the water to form a hydrozonium radical. So basically, when you have your hydrogen from your acid coming together with H2O from your water, because I said earlier that acid is formed when you dissolve it in water. So now this H2O, H plus H2 will give you H3O positive. That's the hydrozonium ion. That is how an acid ionizes. Now you have different definitions of acids. You have the Lewis definition, you have the Arrhenius definitions, and so on and so forth. So, but most other, for example, the Arrhenius definition, some of them define acid in terms of the um, electron donor. Some define acid in terms of proton rather proton acceptor. Yes, so depends on anyhow you want to define the acid, but just know that in acids the only positive ions produced is the hydrogen ion or hydrozonium ion. So and then acids have different properties, and I'll go over several properties. For example, acids are corrosive. That means if you taste an acid, it always tastes corrosive. It kind of wants to burn through materials. And the reason for that corrosiveness is the fact that acids, the way acids are, their nature, they are in such a way that they tend to burn things. And burning is basically involves the process of removing water. So and basically acids are good dehydrating agents. For example, tetraoxosulfate 6 acid, which is also known as H2SO4. So if you pour tetraoxosulfate 6 acid in glucose or glucose solution, the glucose will become charged. It will just turn to simple carbon because the tetraoxosulfate 6 acid has dehydrated it of its moisture. So and that is one property of acids. Many of them are corrosive and they are dehydrating agents. Then we also have the fact that acids turn red bluish muscle power red. So that is a very obvious and physical property of acids. Then we have the fact that acids taste sour. So if you mistakenly have acid in your mouth, it tastes kind of sour and kind of acidic. Yes, it's acidic taste, just like the taste of lemon. So and then lastly, we have one chemical property of acids, very important, the fact that they react with metals to liberate hydrogen. So and then, for example, when we have metals like zinc, metals like let's say sodium, yes, sodium. So acids react with these kind of metals, and whenever they react together, they produce hydrogen. For example, whenever zinc Zn reacts with H2S4, we will get zinc tetroxosulfate 6 ZnSO4 plus H2. So basically, this is just like a double decomposition reaction where the zinc is reacting with is replacing the hydrogen and is depositing the hydrogen gas. So and that is one property of acid. They react with metals to release hydrogen gas. Then next we have method of preparation of acid. There are different methods of preparation of acid. I'll just go over three. The first one is by dissolving their anhydrides in water. And basically, an anhydride is basically a gas from where you can get an acid. And these anhydrides, they are mostly oxides. For example, carbon dioxide is the anhydride of a weak acid, of the weak trioxocarbonate acid. So that's H2CO3. When you dissolve CO2 in water, you get H2CO3. That's a weak acid. Then you also have SO2. When you dissolve SO2, you get H2SO3 and tetrasorbate 4 acid. Then when you dissolve SO3, you get H2SO4, and so on and so forth. So those CO2, SO2, and SO3, they are called acid anhydrides. Another way of getting acid is by when you react them with some sulfides. For example, when you react lead sulfide with or rather lead ethanoate with sulfide, with hydrogen sulfide, you get ethanoic acid and lead sulfide. So that is just another example of double decomposition. Then we also have when you have the displacement of other weaker acids. So when you want to manufacture an acid, you can displace a weaker acid from a solution. So and that when that weaker acid gets displaced, the new acid is formed. For example, when displacement of hydrogen chloride from metallic chloride by the less volatile concentrated H2SO4. So for example, whenever you react sodium chloride with tetrasorbate 6 acid, you will have the product of sodium hydrogen tetrasorbate 6. Then you have hydrochloric acid, which will be formed. So hydrochloric acid will be displaced by the more volatile, by the stronger tetrasorbate 6 acid. That's just an example of how you can prepare acid. Next, we'll talk about bases. So we've gone on and on with acid. So let's come over to base now. And bases, you can't talk about acids without talking about bases, because the base is the one that gives acid its function. So and then we define base also complementary to acids. And I can also tell you that bases are kind of opposite, because whenever you dissolve a base in water and when they ionize, they do not form positive ions, but they form negative ions. So and those negative ions are known as hydroxide, OH minus, OH with a superscript of minus. So and that is the kind of ions that are formed when bases ionize in water. So and then bases can also be known as electron donors, and they can also be known as proton acceptors. So it depends on how you want to define them. You can define them in terms of Arrhenius definition, you can define them in terms of Lewis definitions. So in Arrhenius definition, we can say their bases are proton acceptors, but in Lewis definition, we can say bases are electron donors. So and so on and so forth. There are different means of defining bases and acids, but the standard method is defining them in terms of the ions that they produce when ionized. So next we have properties of bases. Bases also have, some of them are corrosive in nature, but instead of tasting sour like acid, they taste bitter, and they have this soapy feel. They feel like soup. So and that is no mistake, because most of our soap come from bases. For example, whenever you react in a saponification reaction, it's just like a redox reaction kind of. So and then you get your products. So and that product still has it's just like the reaction between an acid and a base, but this time it's the reaction between a fat and an alkanoic acid. So and so on and so forth. So that is organic chemistry. We'll get to there that soon. So and then we'll talk about preparation of bases. So for bases, their preparation are still like similar to those of acids. For example, you can use double decomposition, and for example, also you can also displace you can also produce ammonia by reacting ammonium salts with bases. So for example, when you react sodium hydroxide with any ammonium salt, you always get ammonia produced. So and ammonia is a specific type of weak base, and that weak base is often formed by the reaction of ammonium salts with bases. For example, there are different examples of producing bases. So ammonia is just one example of the base. So moving on. So now, after talking about acids and bases, now we have to talk about neutralization. And neutralization simply means a process whereby acids react with bases to form only two products, which are namely salt and water. But I must remind you that at times you can see an acid reacting with a trioxocarbonate to produce a salt, carbon dioxide, and water. So, and it depends. So that's trioxocarbonate. There are special types of neutralization reaction, but they are still neutralization reaction. You can still consider them as such. But mainly, salt and water is a product produced when acids and bases react. So, and then these salts, there are different types of salts. You have your normal salt, you have your acidic salt, you have your basic salt, you have your double salt, and so on and so forth. So, and then I hope this video has been a great one for you, to give you the overview of acids, bases, and salts. Thank you for watching.